It's you. It's me. Hey, what are you doing here? Oh, that's right. You're on page 336 like I am, and we are continuing our journey in lesson 4. We're talking about the perpendicular bisectors of a triangle. And we're talking about the theorems that we can get from that. So we need to actually go way back. I mean, like so far back in the past months, maybe, into a reminder that any of the content we're going to answer on this page could have been found on page 171 through... insert page number here. I forget where it is, but we're going to go ahead and remind about what that is. You have proven theorems. Let me minimize my face. Small enough. You have proven theorems related to triangle congruence. You know that two triangles are congruent when three corresponding sides are congruent. So a reminder of this is all the way back in, oh my gosh, this book is destroyed. Proving triangle congruence theorems all the way back on page 171. And as we went through the different statements, we had the proofs for side angle side, for side side side, for angle side angle, etc. Page 171 all the way up through page 184 and beyond would be a good review for us to kind of remind about why some things are true for what we have here. Three corresponding sides are congruent is side, side, side. We have three matching sides. Two corresponding sides and the included, it's meaning it's between, the included angle are congruent. Two sides, one angle, SAS. Two corresponding angles and the included side are congruent. So that's two angles, one side, put the side in the middle. That makes ASA. Let's use those three congruence theorems to explain why triangle ABC and triangle DCE are congruent. I'm going to use a highlighter. I'm going to highlight the fact that that orange double spike line and this orange double spike line are congruent. I'm going to use a different color highlighter because single spike AC and single spike EC, those are congruent. And then last of all, when you have two lines crossing, the angles that are formed between those two lines crossing are vertical angles and they are congruent. So here's an angle, here's an angle. In both of those triangles, there are two sides, the angle between those two sides, this must be SAS. Let's make a list of why it is. First reason, segment BC is equal to segment DC. That's the double spike. I don't know why double spike went first, but it did. The second bullet point is angle ACB is congruent to angle ECD. That's the A in SAS. And then last of all, the single spike line AC equals EC. That is the way we show SAS. Color statements done. Part B. Same thing. We've probably used SAS, so we're not looking for an SAS reason again, but it could happen. It could happen. Okay, colors, ready? We have three statements we got to make, so have three colors ready to go. Let me swap in pink for orange. Okay, double spike gets the pink. Single spike gets the green. And you know what? One of our vocabulary words, where did you go, vocabulary words? It's called reflexive property. And so I've been pretty good at finding these things right away without much hassle. Reflexive property, got transitive property. I've got definition alternate. Somewhere in here is reflexive. Oh, there's vertical angles. Vertical angle, that was for the first one, right? Reflexive property, reflexive property. I'm hoping I can find it. I'm stalling for time. It's not going to happen in this video. The point is that I wanted to say reflexive property because when you have these two triangles sharing a common line, the reflexive property is the reason why we get to say that they are congruent. Turns out, side, side, side. SSS, make the list. BC is equal to DA. And CD is equal to, get out of here, face, is equal to AB. So that's pink, green, and now yellow. AC is equal to AC. That would actually be a good idea. Let me highlight. So pink, green, yellow, orange, green, yellow. We got one more. Let's finish this one out. Here we go, here we go. There's only one option left, really, okay? But we're gonna have to kind of dig for it a little bit. The first one I'm gonna acknowledge is that these two triangles still share a common side. They share AC equals AC. That's the reflexive property, everyone. It's AC for that triangle, and it's AC for this triangle, and it's the same AC, so it's reflexive. We have parallel lines here, right? These arrows mean that those two lines are parallel, and these arrows mean that those two lines are parallel. If we have parallel lines cut by a transversal, AC is the transversal, then that means that this angle, so that's the one at angle A, CAB, and this angle, that's the one at angle C, ACD, they're congruent because alternate interior angles are congruent. So I'm going to list the angles that match. Angle BAC is congruent to angle DCA. One more. Still looking at how we have parallel lines cut by a transversal, but let's focus on the other parallel lines. Let's focus on these parallel lines. This angle, BCA, is congruent to this angle, DAC. You got to write it out with the letters in the proper order, mind you. So coloration happens. It makes things a little easier to follow. We're going to say angle BCA is congruent. So that's this angle up here is congruent to angle DAC. That's that angle down there. And if you look at it, we have a side, and we've mentioned two angles. And there's only one more multiple choice option of the different types of ways to prove that triangles are congruent. It must be ASA.